Hello, everybody. We have Michael Lombardi here with us from a Subsalve, and he will show a great setup for his helmet for the non-invasive ventilation. Hello, Michael, and very nice to have you here.
Thanks. Happy to be here. So, yeah, I'll just, over the last couple of weeks, I've been looking at various respiratory circuits to connect to the helmet and try to gain some features through off-the-shelf components. So I was hoping to just share those, and we can talk through it a little bit.
Yeah.
So I'll start on the inspiratory limb. One of the questions that's often come up is if you had a gas supply failure and there's potential risk of CO2 rebreathing, how can you very quickly open the hood to get fresh air access for the patient? So one solution is a zipper, or another solution might be a port. There's lots of things you can do to the hood itself to get that access. But then I started thinking about what can you do in the respiratory circuit to just create an open loop rather than a closed loop. And there's an off-the-shelf component here, which is this is a Respironics piece, and it's a one-way directional valve. So this little blue piece is spring-loaded, so the flow comes in on the spring side to open the valve. That lets flow pass through, and if flow fails, it leaves these three ports on the side open. And what this valve is intended for is so that if you had condensate or fluid or any kind of drainage from a CPAP mask, rather than make its way back to the machine and damage the machine, it would flow out of this part. But the most important thing is that it fails open.
Yeah.
So if you have a failure, even with the helmet ventilation, it's just simply going to fail open, which means the patient's no longer enclosed in the hood. They're in the hood, but it's open to ambient. Now, this of course needs to be tested to determine how much fresh gas can be drawn through that port. I'd suspect over time there's still some CO2 buildup in the hood itself, but this could be a pretty effective way, an easy way for any of the helmets out there to make the hood open instead of closed in an emergency.
So at what flow does the valve open?
It opens at very, very low, 2 centimeters of water, I believe. And it's just a spring against a disc with a little silicone seal. Very simple part. So things that could be tested down the road are would you want this very close to the hood? Could it be, in this instance, is it a 100 cc hose length away from the hood? Is it better to be on the inhale side or the exhale side? Maybe you could configure it to be on both. But it's an important part that we discovered and may be able to be repurposed for helmet ventilation. Now, the stuff I'm really excited about is on the expiratory side. So one of the other challenges is pressure relief. So when we're using the hoods for COVID, one of the most important benefits is that you're filtering out aerosolized virus with these viral filters. The viral filters can clog fairly easily with condensate. We've found even in humid environments where you don't actually have water, just in the humidity over time, they clog up. So this is a more conventional expiratory limb for the helmet ventilation, which consists of I like to use the short 100 cc section hose just for patient comfort, so it gives some flexibility right at the hood, a viral filter, and then a PEEP valve. And in this typical configuration, your viral filter is down. And what I don't love about that is any condensate or other fluids coming from the helmet are obviously going to run down directly into the filter. So that's where our concern with filter comes into play. And if the filter gets clogged, of course, the pressure is going to raise in the hood to some point, and then there's the need for an overpressure relief valve.
Mm-hmm.
So again, with some off-the-shelf components, I reconfigured the expiratory limb to address a couple of concerns. So in this configuration,
Mm-hmm.
I put the standard expiratory limb pointed up, and by pointing it up, no fluid is going to run down into the filter, obviously, so you have gravity working with you. You still have your PEEP valve to control pressure. And then I added a second PEEP valve down low.
Okay.
So being positioned down low, it serves functions. One is you can set it a little bit higher than your primary PEEP valve. So if your primary PEEP valve, if this filter gets clogged and you can no longer use your primary PEEP valve, your secondary PEEP valve will kick in and act as your overpressure valve. So let's say your primary is set at 10 centimeters and your secondary is set at 12 or 15 centimeters. It acts as your overpressure valve. It also reduces any significant pressure increase where some of the off-the-shelf relief valves go. So I think some of them actuate at 40 centimeters of water, which sounds like it could be potentially very dangerous. So particularly if a treatment is at 10 centimeters or less, if that valve doesn't actuate until 40 centimeters, that's a long way to go for the patient. So the other thing I like about the low positioned PEEP valve is should you have fluid pool up, you can drain it. So you could wrap this in a towel or something to just catch the fluid. You could open it up and everything will just drain out. All the moisture will drain out. So
and it's nice that you're using all these accessories. It's off the shelf, so you can get it in any respiratory department.
Yeah.
Nice.
So inspiratory side is that respironics valve, which gives you potentially emergency breathing capability. And then your expiratory side is your backup drainage PEEP valve, and your primary filter and PEEP valve pointed up rather than down.
Yeah. So definitely it's going to save the filter. It will last for longer.
Yep.
And then you do have another piece, that three-way connector. So it's
I do, yes.
Yeah, so I want to see that too. That was developed by you, by your team.
Yes. So we just started prototyping these freeway connectors, and it's kind of a multi-function part. So it's everything connects with the standard 22 millimeter connections. In this configuration, you can have any combination of air and oxygen teed in with your standard oxygen lines. Everything's capped to keep it clean. Or alternatively, you can run in from a BiPAP, CPAP, ventilator, any flow source, and then additionally tee in oxygen, one or two sources. So it's kind of a multi-function component that could be an important part of the toolbox moving forward.
So that can be used with all these portable machines that can create that flow. So, for example, I know that you work with a couple teams in US who developed those machines that can be used in underdeveloped countries. Can you tell me more about it?
Yeah, so there's a project here in Rhode Island called ventilatorproject.org, run by Alex Hornstein, who's a colleague. And he's one of several groups in the country, in the world really, that have sought to collect donated home use CPAP units. And reason being that they are a good flow source, they're reliable, they can run for long periods of time. And in principle, they can run a helmet ventilation system. What they don't have is a very clean and easy way to additionally titrate in oxygen or control flow. So there are there is some testing, experimentation going on to develop, a series of titration tables for modified CPAP helmet ventilation. And I think that's really an important ticket for these, low resource settings where, now you can have a hood plus a donated CPAP and the collection of parts and pieces to make up a circuit for, less than $500. That $500 versus a $20,000 ventilator that these places will never have is a big deal. So we've had input from several hospitals in other places, those that come to mind, Nigeria, Philippines, and a few places in Central America where that kit, the hood, combination of the hood, the CPAP unit, and the correct parts and pieces have made it there. They've been evaluated, and their ministries of health are, authorizing that for their emergent use, which is really good.
Great news, yes. And there is another team, right, that you work with. They working with government from Bangladesh. They also developed a small ventilator, I would say, BiPAP machine.
Yeah, so we just had an initial conversation with Yasser Khan out of Stanford and his newly developed system, which I think is fantastic. It could be a real game changer in terms of having an affordable but purpose-built flow from a BiPAP unit. But it specifically controls for flow, which is fantastic. It has built-in alarms and the ability to titrate oxygen through the device. So it's a really, really nice device, and I hope he's successful.
Yeah, I'm so happy to hear all these teams actually connecting now, and your helmet can be used in other countries that don't have that reliable gas flow in hospital settings or outside the hospitals. So great progress. Thank you, Michael. And just want to mention that the Subsalve helmet is in the process of getting FDA approval. And we hope to see the positive results very quickly. And thank you, Michael. Do you have anything else to add to this video?
No, just it's been an incredible couple of months getting involved in the helmet ventilation initiative. And I think it's important for just the community to recognize that this is incredibly important work that all the companies are doing. And, we're not out of the woods with COVID response yet. So this technology needs to be taken seriously, and it will definitely make a big impact.
Yeah, and I just want to add to this that today is June 5th, and we're already seeing a second spike of COVID-19 patients in the US. So I just wanted to give everyone advice to get ready and prepare. We want to make sure that we have all the supplies, all the equipment, especially for the respiratory distress, ready in the hospitals and outside the hospitals. I do hear other countries, especially in the southern hemisphere, already made helmets, and we're getting ready to use it for the patients in their hospitals. And well, I just want to say thank you to Michael and your team, because you guys been on top of all the requests that we have from clinicians, from nurses, and you developed a really great helmet. And also I'm happy that you can produce in a high quantities if needed. So I hope your helmet will save a lot of lives. Thank you so much, Michael.
All right, thank you.